My name's Isabel, and so for our the Lexington group created a book recommendation system, and so it's you input a book that you've read, and the website will give you a list of recommendations based off of that book and a similarity score. But to start with our group, so on the front end of the programming, we had Suki, Alec, and then on the data side, we had Alex and Max. But then to start with our mission, hand it over.
So finding your next book is hard, especially with the overwhelming number of genres and subgenres. However, reading is very important and very helpful. So our mission is to provide a search tool that helps you find your next book and explore books similar to books you have read. So now Suki will explain more about the data aspects.
After we determined our mission, we browsed through Kaggle to find a dataset. Kaggle allows users to find and publish datasets, explore and build models in a web-based data science environment, work with other data scientists and machine learning engineers, and enter competition to solve data science challenges. Then after voting on which data to use and how to use it, we collectively decided on the book summary data. It provided information on the book's Wikipedia ID, free database ID, title, production date, genre, and plot summary. We then downloaded the file and imported into CodeCalc to further analyze the data. Next, we will have Alex explain how the data was cleaned.
After we collected our data set, we realized that the book titles and descriptions were already in the proper format, so we had very little cleaning to do. This meant that all we need to do was filter the data by removing blank entries, duplicates, and unnecessary data such as the publisher or book ID. This allowed our dataset to be in the proper format for training using Doc2Vec, which Max will now explain.
So to train our model, we used Gensim's Doc2Vec algorithm. Gensim is an open source Python library that lets you numerically represent the meaning of words. So one method it provides is Word2Vec, which could represent the relative meaning of words through vectors by looking at the context of each word and which words appear in similar places in a text. So Doc2Vec, which is what we used, is an adaptation of Word2Vec, which combines these word vectors to produce a vector for each document in our data set. So now given a book in the data set, we can use the vector model to find the most similar books to it. But searching through every possible document to find the exact most similar vector is pretty inefficient, and we discovered that we didn't really need to do that. So we used Spotify's Annoy, approximate nearest neighbors oh yeah indexer to find approximate results in a much more time efficient manner. So that lets us serve results without making the user wait forever for it to find the best possible solution. Now I'll hand it off to Alec to talk about our website.
For our website, we used the app NicePage to customize and create the design of our website and imported it into our server. There are many issues surrounding the inability for CSS, which is a portion that allows the website to show up properly in the browser. And there are also issues with the files themselves. But after exporting the HTML files from NicePage with the CSS successfully, we were able to connect the HTML files to Flask, which is a Python module that assists the web development process. After that, we debugged the integration of our book recommending function into our website. Speaking of our website, it will be deployed this evening at book-recommender.ai-camp.com. I'm going to hand it over to Izzy, who's going to demo our book recommender.
Just give me 2 seconds to pull it up. Sorry. Okay. So the way our system works, or the way our website works, is when you start typing, it gives you a list of books that are in our data set. So if we start with looking at, say, Animal Farm, You just type in the book and hit search, and it takes a second, but it'll spit out 4 recommendations every time. And so these recommendations are in the form of a summary, and these summaries tend to be relatively long. And then after that, there is the title and a similarity score. So this similarity score is generally telling you how similar the words are in the book. And so you'll get, and so, sorry. And so for like Animal Farm, you'll get a lot of books that have 56, so lower similarity scores, because they use a lot of, general words outside of, or general words and ideas. But if you were to look at a book like An Inquiry Concerning Human Understanding, which talks a lot about Freud and his specific ideas, then once it loads, you'll see that like the books that you get recommended have higher similarity scores, and they also talk about a lot of the same more specific ideas and use the same sort of language. Although it doesn't seem to want to load at the moment. But if it does, the scores tend to be in the like 76 range rather than here where they're in the 56 range.
Maybe give it a refresh. Sometimes that helps.
But it gives you you get 4 recommendations for each one, and then that's the
Bandwidth definitely gets strained sharing screen and leading your talk. Izzy, you cut out a little bit there at the end.
Oh, sorry.
It's okay. All right. Round of applause for Lexington. Great job, guys. That is really